Good morning, students. Today I am going to discuss derivatives of exponential and logarithmic functions. So, before going to derivatives of exponential and logarithmic functions, firstly I would like to discuss about the exponential functions and logarithmic functions. So, basically, exponential functions and logarithmic functions are inverses of each other. So, first thing I am going to discuss briefly on the exponential function. So, what is meant by an exponential function? So, any function is of the form y is equals to a power x, where a should be greater than 0 and a should not be equal to 1. Such type of functions are called as exponential functions. So, here what is the conditions? A should not be equal to 1. Why? Because if I consider a is equals to 1, 1 power anything is always 1. So, it means there is no use of exponential format. That's why we are not considering a is equals to 1. And one more thing, a is not equal to 0 because 0 power anything is always 0. So, it means there is no use of exponential format. That's why a should not be 0 and a should not be 1, and as well as a should not be a negative number. So, a greater than 0 in the sense a is always a positive number. Why? Because if I consider a is a negative number, so minus 2 power 1 by 2. So, here base is 2, exponent is 1 by 2. So, we know that minus 2 power 1 by 2 is equal to what? Square root of minus 2. So, it means square root of minus 2 does not belongs to real numbers. So, it means exponential functions doesn't consist negative number at its base, because for some domain values it doesn't belongs to set of real numbers. So, that's why here in exponential format the base should not be equal to 0, should not be equal to 1, and should not be a negative number. I hope all of you understood. So, what is meant by an exponential function? Any function is of the form a power x, and the conditions are a greater than 0 and a should not be equal to 1. Such type of functions are called as what? Exponential functions. So, let us consider one of the example. Suppose y is equals to 2 power x is one of the exponential function. Here in this function, what is the domain of this function? What is the range of this function? To understand domain and range of this exponential functions, let us draw the graph of this function. So, as you know that graph ಹೆಂಗಾಗ್ತಾರಂತ ಗೊತ್ತುಂಟು ನಿಮ್ಗೆ. First we need to consider the x-axis, and this one is a y-axis. And as you know that this is what? Origin, and this is a positive x-axis, positive y-axis, negative x-axis, and negative y-axis. So, 1, 2, 3, 4, and left side of the origin is minus 1, minus 2, minus 3, and above the origin 1, 2, 3, and below the origin minus 1, minus 2, minus 3. So, first these are the values of x and these are the values of y. So, to draw the graph of this function, let us consider some values for x and what they gives the output values. When x equals to 0, 2 power 0 is 1. Therefore, when x is 0, y is 1. When x is 1, y is 2. 2 power 1 is 2. So, when x is 1, y is 2. So, when x is 2, 2 power 2, y is 4. So, when x is 2, y is 4. So, here 3 means 4. And so on. So, when x is 3, y is 8. When x is 4, y is 16. When we consider the values of x is equals to negative number. So, when x is minus 1, so it means 2 power minus 1. We know that 2 power minus 1 is 1 by 2 and the value of 1 by 2 is 0.5. So, when x is minus 1, y is 1 by 2. It means 0.5. So, y is 0.5. And when x is minus 2, value of 2 power x means 2 power minus 2. 2 power minus 2 means 1 divided by 2 power 2. 1 divided by 2 power 2 is 1 by 4, and the value of 1 by 4 is 0.25. So when x is minus 2, y is 0.25. And when x is minus 3, definitely it is less than 0.25. And so on. So when x is minus infinity, 2 power minus infinity, it means 1 divided by 2 power infinity. It means 1 divided by infinity, because 2 power infinity always gives an infinity value. So therefore 1 by infinity value is 0. But we know that infinity is not a definite number. So it means the graph of 2 power x doesn't meet x-axis. The value of y should not be a 0, because infinity is a indefinite number. So that's why the graph of this exponential function is, the graph of this exponential function is, see here. So this is a nature of graph of what? Y is equals to 2 power x. So now observe here, when we are taking the value of x, for all values of x, this function is defined. So for any value of x, 2 power x is defined. It means we know that the set of input values are called as a domain of the function. So it means the domain of exponential function. Can we say that it is set of real numbers? Of course. So this quantity 2 power x is defined for all values of real number, or for all values of x. So therefore domain of the function, or domain of the exponential function, is set of real numbers. And what is the range of this function? So range of the function is, observe here, we know that the set of all output values are called as a range of the function. So by the nature of graph, we may observe that the value of y cannot be a negative, cannot be a negative. So if I consider x is equals to infinity, so 2 power infinity is equals to infinity. Therefore, the output values may also give up to infinity from 0. Therefore, range of the function is 0 to infinity. I hope all of you understanding. The domain of the exponential function is set of real numbers, and the range of exponential function is 0 to infinity, or we may call it as set of positive real numbers. I hope all of you understood. So now what? Logarithmic function. So logarithmic function is a function which is derived from the exponential function. So as you know that exponential function is of the form y is equals to a power x. So from this only we are going to derive what? Logarithmic function. So logarithmic function is obtained by shifting this base a towards the left side. When we shift the base towards the left side, automatically it converted as a log format. So if I shift a towards the left side, it becomes log y to the base a is equals to x. So this is called as what? Logarithmic function. So and one more thing you need to observe here, when we are discussing the exponential function, I already discussed x is what? Set of input values. So we know that set of input values are called as domain. And what is the domain of the exponential function? We already know set of real numbers. And what is the condition on this base a? A should be greater than 0 and a should not be equal to 1. And what is y? Y is nothing but output of the exponential function. So set of output values of the function are called as what? Range of the function. And we know that range of the exponential function is set of positive real numbers, or from 0 to infinity. So now observe this. From this we may conclude that x is a output value of the logarithmic function, and this y is a input of the logarithmic function. So it means when x is a output of the logarithmic function, it should be equal to input of the exponential function. So it means if x is output of the logarithmic function, the set of output values are called as range of the function. And what is the range of this logarithmic function? It is nothing but domain of the exponential function. So therefore, range of the logarithmic function is set of all real numbers. And what is this y? Set of all input values. So we know that set of all input values are called as domain of the function. So this y in exponential function are considered as a set of output values and it is range of the exponential function. So therefore, by observing this, the range of exponential function is nothing but domain of the logarithmic function. So what is domain of the logarithmic function? By observing this, we conclude that set of positive real numbers. I hope all of you understand. And one more thing, what is a condition on the base? Condition on the base is a should be greater than 0 and a should not be equal to 1. So this is all about what logarithmic function. Now what? Derivatives of exponential and logarithmic function. So already we studied the formula for derivatives of exponential and logarithmic functions in the first P only. So here directly I am going to write the formulas. The first formula, derivative of exponential function a power x is equals to what? A power x into log a to the base e anta ಬರಿಬಹುದು. And next, the derivative of, if suppose a power instead of x he has given any one of the function of the form fx, so then the derivative of a to the power fx is equals to, same thing here, x is fx, so as it is a power fx into what? Log a, and into derivative of fx, that is what? F dash x, because we need to use here chain rule. And next, derivative of e power x. So derivative of e power x is e power x. And next, derivative of log x base e is equals to, so derivative of log x to the base e is equals to 1 by x. Find the derivatives of the following function. Find the derivatives of following functions with respect to x. So first question is, so y is equals to e power minus x. Now we need to find the dy by dx because derivative with respect to x. So we need to find what? Dy by dx. Therefore, differentiate this with respect to x. Derivative of y with respect to x is dy by dx equals to derivative of e power fx is equals to derivative of e power fx is equals to, we know that e power fx into a derivative of f dash x, because exponential is in a composite form. So derivative of e power minus x is e power minus x into derivative of what? Minus x. So therefore, dy by dx is equals to dy by dx is equals to e power minus x into derivative of minus x with respect to x is minus 1. Therefore, final answer dy by dx is equals to minus e power minus x. Now let us consider the second one. If suppose y is equals to a power 3x, then find dy by dx. So further differentiate this with respect to x. Differentiate this with respect to x. Derivative of y with respect to x is dy by dx, which is equals to derivative of a power 3x. Derivative of a power 3x. So dy by dx is equals to, we know that derivative of a power fx is equals to what? A power fx, a power fx into log a into derivative of fx, that is f dash x. Therefore, derivative of a power 3x is a power 3x into log a into what, derivative of 3x. So, therefore, dy by dx is equals to a power 3x into log a into derivative of 3x with respect to x is 3. Therefore, final required dy by dx is equals to dy by dx is equals to 3 into 3 into a power 3x into log a. I hope all of you understanding. Let us consider some more examples, then we go for the NCERT problems. So find dy by dx for the question, or for the y is equals to log of 2x plus 3. So if he doesn't give any base, then understood it is a natural log. So it means here base is what? 2. If they may give or may not give, so if he has given, okay, no problem, log base is e. If he doesn't give any base, then we consider what? Base is always equals to e. So now we need to find the derivative of this function. So for that, differentiate with respect to x. So dy by dx is equals to. So we know that derivative of log of something is 1 divided by something. 1 divided by something, that is 1 by 2x plus 3 into what? Derivative of 2x plus 3. So therefore, dy by dx is equals to derivative 1 divided by 2x plus as 3 into derivative of 2x plus 3 is 2 into 1 plus derivative of constant is 0. Therefore, dy by dx is equals to dy by dx is equals to 2 into 1, 2 divided by 2x plus 3. I hope all of you are understanding. Let us consider one more example. So if y is equals to e power cos inverse x, and we need to find the dy by dx. So for the differentiate this with respect to x, derivative of y with respect to x is dy by dx into e power x format. Derivative of e power cos inverse x is e power cos inverse x into what? Derivative of cos inverse x. Therefore, dy by dx is equals to e power cos inverse x into derivative of cos inverse x is minus 1 divided by square root of 1 minus x square. Therefore, required dy by dx for the given exponential function is e power cos inverse x divided by minus square root of 1 minus x square. I hope all of you understood. Let us start the exercise number 5.4. Now I am going to discuss what? The questions from the exercise 5.4. So in this exercise, the questions regarding with the derivatives of exponentials and logarithmic functions. So here the question is, find the derivatives of the following functions with respect to x. And the first question is, y is equals to e power x divided by sin x. Y is equals to e power x divided by sin x. So now we need to find a dy by dx for this function. So observe here, the given function in which format? In u by v form. So we know that the quotient rule. So that is what? Derivative of u by v. Derivative of u by v is equals to v into u dash minus u into v dash divided by what? V square. So here u is e power x, v is sin x. So differentiate this with respect to x. So therefore dy by dx is equals to divided by v square means sin x square. So v as it is, sin x as it is, into derivative of e power x minus u as it is, e power x as it is, into derivative of v is derivative of sin x. I hope all of you understanding. Now therefore dy by dx is equals to dy by dx is equals to, so sin x as it is into derivative of e power x is e power x minus e power x as it is into derivative of sin x is cos x divided by sin x whole square can be written as sin square x. So finally we got dy by dx is equals to dy by dx is equals to, so in numerator here we may take e power x as common, taking e power x as a common, remaining sin x minus cos x divided by sin square x. I hope all of you understanding. So now the next second question is y is equals to e power sin inverse x. So now differentiate this with respect to x. We know that derivative of y with respect to x is dy by dx, and derivative of e power sin inverse x is e power sin inverse x into derivative of what? Sin inverse x. So therefore dy by dx is equals to e power sin inverse x as it is into derivative of sin inverse x is 1 divided by square root of 1 minus x square. So finally we got dy by dx for the given exponential function is e power sin inverse x into 1 e power sin inverse x divided by square root of 1 minus x square. I hope all of you understanding. So now the next third question is find dy by dx for the function y is equals to e power x cube, e power x cube. So therefore differentiate this function with respect to x. So derivative of y with respect to x is dy by dx into derivative of e power x cube is e power x cube into what? Derivative of x cube, because it is of the form e power fx format. So therefore dy by dx is equals to e power x cube into derivative of x cube is 3x square. Therefore required dy by dx is equals to 3x square into e power x cube. So I hope all of you understanding. Now the fourth question is find dy by dx for the function y is equals to sine of tan inverse e power x. So we need dy by dx, therefore differentiate this with respect to x. So derivative of y with respect to x is dy by dx. So now derivative of sine of something is cos of something, that is tan inverse of e power x into derivative of something, that is what? Derivative of tan inverse of e power x. So therefore dy by dx is equals to cos of tan inverse e power x into derivative of tan inverse something is 1 divided by 1 plus something square, because we know that derivative of tan inverse x is equals to what? 1 divided by 1 plus x square. Here x is e power x into derivative of what? E power x. So therefore dy by dx is equals to, therefore dy by dx is equals to cos of tan inverse e power x divided by 1 plus e power 2x into derivative of e power x is e power x. So finally required dy by dx is equals to required dy by dx is equals to e power x into cos of tan inverse e power x divided by 1 plus e power 2x. I hope all of you understanding. So now the fifth question is find dy by dx for the function log of cos e power x. Log of cos e power x. So we need dy by dx. Therefore, differentiate this with respect to x. So therefore, dy by dx is equals to derivative of log of something is 1 divided by something into derivative of something is cos e power x. So therefore, dy by dx is equals to 1 divided by cos e power x into derivative of cos of something is minus sine of something into derivative of something, here something is e power x. Therefore, dy by dx is equals to minus sine e power x divided by cos e power x into derivative of e power x is e power x. So therefore, required dy by dx is equals to minus sin e power x divided by cos e power x is tan e power x, tan e power x into e power x as it is. So hence finally dy by dx is equals to minus e power x into tan e power x. I hope all of you understanding. Now the sixth question is find dy by dx for the function y is equals to e power x plus e power x square plus e power x cube plus e power x raised to 4 plus e power x raised to 5. So we need dy by dx. Therefore, differentiate this with respect to x. So derivative of y with respect to x is dy by dx equals to derivative of e power x plus e power x square plus e power x cube plus e power x raised to 4 plus e power x raised to 5. So we know that from the algebra of the derivatives, from the algebra of the derivatives, derivative of u plus v is equals to derivative of u plus v is equals to derivative of u plus derivative of v. So by using this algebra of the derivative, this can be written as derivative of e power x plus derivative of e power x square plus derivative of e power x cube plus derivative of e power x raised to 4 plus derivative of e power x raised to 5. So therefore required dy by dx is equals to derivative of e power x is e power x plus derivative of e power x square is e power x square into derivative of x square is 2x plus derivative of e power x cube is e power x cube into derivative of x cube is 3x square plus derivative of e raised to x raised to 4 is e raised to x raised to 4 into 4x cube plus derivative of e power x raised to 5 is e power x raised to 5 into 5 into x raised to 4. So therefore final answer dy by dx is equals to e power x plus 2x into e power x square plus 3x square into e power x cube plus 4x cube into e power x raised to 4 plus 5x raised to 4 into e power x raised to 5. I hope all of you understood. Now, the seventh question is find dy by dx for the function y is equals to square root of e power square root of x. So, to find dy by dx, differentiate this with respect to x. So, derivative of y with respect to x is dy by dx equals to derivative of square root of something is 1 divided by 2 into square root of something into derivative of something. So, derivative of here something is e power root x. Now, so dy by dx is equals to 1 divided by 2 into square root of e power root x as it is into derivative of e power something is e power something into derivative of what? Something. Therefore, required dy by dx is equals to dy by dx is equals to e power root x divided by 2 into square root of e power root x into derivative of root x is what? 1 divided by 2 into root x. So, therefore, final answer for derivative of y with respect to x is e power root x divided by 2 into 2 4 into square root of x into e power root x. I hope all of you understood. Now, the eighth question is find dy by dx for the function y is equals to log of log x. So, now differentiate this with respect to x. So, dy by dx is equal to derivative of log of something is 1 divided by something into derivative of something. So, first thing derivative of this log is 1 by log x, then derivative of log x. Therefore, dy by dx is equal to 1 divided by log x into derivative of log x is 1 by x. So, finally, dy by dx is equal to 1 divided by x log x, x into log x. I hope all of you understanding. So, now the ninth question is, take this ninth question, y is equals to cos x divided by log x as your homework. So, this can be solved by using what? Quotient rule, that is what? U by v, where u is cos x, v is log x. And the 10th question, so I am going to solve this 10th question. Find the derivative of y is equals to cos of log x plus e power x. So, to find dy by dx, differentiate this with respect to x. So, derivative of y with respect to x is dy by dx equals to derivative of cos of something is minus sine of something log x plus e power x into derivative of something. So, something is log x plus e power x. Now, so dy by dx is equals to minus sine of log x plus e power x into derivative of log x is 1 by x plus derivative of e power x is e power x. So, therefore, required dy by dx is equals to minus of 1 by x plus e power x into sine of log x plus e power x. I hope all of you understood.